everyone, it's Olivia here from Olivia's Online Tuition, and today is day 4 of my 25 Days to a Better Maths Grid series, and today is fractions. So as always, we'll do a couple of questions first, then on to exam questions. They do get really tough today, so stick with it. But yeah, let's get to it. Okay, then first question, work out 1/10 plus 3/5. So what we need to do here, if we're adding or subtracting fractions, we need to make the denominators the same by either making one of the numbers into the other or by changing both of the numbers, making them into a common multiple. So with this one, however, we can just make this 5 into a 10 by timesing it by 2. What we're going to do here is multiply this whole fraction by 2. So we're going to get 1/10, that's going to stay as it is, plus times all that by 2. We're going to then get 3 times 2, which is 6, over 5 times 2, which is 10, and add those together, 7/10. Work out 2/3 minus 1/4. So in this case, we can't make one of the numbers into another without making it some really horrible decimal, right? So what we do in this case is change both of the numbers into a common multiple. So what is a common multiple of 3 and 4? That's going to be 12, right? Because 3 and 4 both go into 12. So what we do then is times this one by 4 to get it to 12, because 3 times 4 is 12. So 2/3 times 4, or 4 over 4, I should say, which is then 8 over 12. And then for 1/4, I'm going to do 1/4 times 3, because 4 times 3 is 12. So 1/4 times by 3, that is then 3 over 12. And then we have 8/12 take away 3/12, which is 8, 7, 6, 5/12. And there we are. That's that. And work out 3/4 times 4/9. Give your answer as a fraction in its simplest form. So multiplying fractions is even easier than adding and subtracting. All we need to do is times along the top and times along the bottom. So we're going to do 3 times 4, which is 12, over 9 times 4, which is 36. And then we can simplify this fraction. And simplifying a fraction, what that means is essentially, can you divide both of these numbers by the same thing? And I always start with 2. Can I divide both of these numbers by 2? Yes, I can, because these guys are both even. If I divide them both by 2, then get 12 divided by 2, which is 6, over 36 divided by 2, which is 18. And then can I divide them by 2 again? Yes, I can. And by 2 again, I then get 3 over 9. Then can I divide them both by 2 again? No, I can't. So can I divide them by 3? Yes, I can. Divide them both by 3 and then get 1 over 3. Or you could have divided it all by 12 to jump straight from there to there. But if you can't see that, doesn't matter. Just keep going, keep whittling it down until you get to the smallest thing you possibly can. There we are. That's multiplying fractions. Next up then, dividing fractions. So work out 1/7 divided by 3/4. So for this, you need to use KFC. Keep, flip, change. So you keep the first one, you flip the second one, flip it upside down to get 4 over 3. Then you change the sign to a times. So you keep the first, flip the second, and then change the divide to a times. And then from here, it's just times in fractions, times on the top, times along the bottom, to then get 4 over 21. Okay, the next one, work out 2 and a 5th plus 1 and a 7th. So this is what we call a mixed number or a mixed fraction, right? And those I do not like. So what I always do is convert any mixed number I see anywhere in my paper to an improper fraction, which is just essentially just a regular fraction, number on top of number, right? With no big numbers around. So how we do that, so what we do first is, I'm going to write it out here so I can see it a bit better, separated from the question. What we do then is we always multiply the big number by the denominator, which is then 10, and then add on the numerator, which gives our top number of 11. So times these together, add whatever's up there, that gives you whatever's up there, right? And then denominator is always the same. So the one on the max number is always going to be the one on the fraction as well. So 11 over 5. And then same thing for 1 and a 7th. We're going to then times 1 by 7, 7, add 1, 8 over 7. And there we are. And then adding these together, 11 over 5 plus 8 sevenths. So remember, adding fractions need the same denominator. So we need to figure out what number is in both the 5 and the 7 times tables. So you may think immediately, oh, that's 35. But if you struggle to see it, like I sometimes do, what you need to do with that is then just multiply these together, and that will always give you a multiple. May not be the simplest multiple, but will be a multiple, right? And that's all you need. So multiply them together, that is also 35. So what we're going to do there then is convert both of these fractions to be over 35. So then to get this one into 35, you multiply by 7. So also times the top one by 7, so you get 77. And then 7 here has been multiplied by 5 to get 35. So 8 times 5, that is then 40. And then add these together, we then get 77 plus 40, which is 7. And then what is that? 7, that's that 11. So there we are, 117. 117 over 35. Okay, next one then, work out 1 3/4 times 1 1/2. Give your answer as a mixed number in its simplest form. So even though it's asking us to leave it as a mixed number, I would still proceed with the same method. Whenever you see a mixed number, convert it into an improper fraction. We'll just put it back into a mixed number at the end, that's all. Because mixed fractions we don't know how to work with, but improper ones we do. So let's start off then. So we've got 1 3/4. Let's make that into an improper fraction. So 1 times 4, that's 4, plus 3, that's 7 over 4. And then 1 1/2, 1 times 2, 2, add 1, 3 over 2. And then 7 over 4 times 3 over 2 times top times bottom, and 7, 14, 21 out of 8. Then can we simplify this? Don't think so, because 2 doesn't go into this one, 3 doesn't go into this one, so then 4 doesn't, and then the other one left is 8, which doesn't go into this one either. So we're finished there. Next up then, converting it into a mixed number. So the way we do this is kind of the reverse of this. So we figure out how many 8s fit in to 21. So then we do our 8 times tables, that's then 8, 16, 24. So only 2 8s fit into 21. So we'll put a big 2. And then how many is left over, that's going to then go on top here. So how many is left over? To get from 16 to 21, that's 4 to 20, then add 1, 5. So then 5 goes up there, out of, denominator stays the same as it always does. That's then 8. Okay, next one then, find 1/6 of 420. So for this, 1/6 stays as it is, but the of gets changed. So of in maths always means times. So then if you do 1/6, then times 420. That's always the case. If you see the word of in maths, it's always going to mean times. And then what we can do here is, so we've got a 6th, which is a fraction. We have got 420, which is not a fraction. So in order to do the maths we've just been doing, can we make 420 into a fraction? And yes, we can. What we can do is divide it by 1. If we divide it by 1, it's not really changing the number, is it? Because how many 1s are in 420? 420, right? So it's not changing the number, just making it a little bit more convenient, right? And then from here, it's just fraction maths. Nice and easy. Times the top, times the bottom. So 1 times 420, that is 420. And then 6 times 1, that is 6. And then can we simplify this? Yes, we can. Divide it by 2 because they're both even. So then we get 210 divided by 3. And then can we divide the top one by 3? Yes, we can. If you add all the digits in a number and it's a multiple of 3, it will divide by 3. So then divide this by 3. Let's have a look then. Maybe do a bit of bust up if you like. Let's do that. 210 divided by 3. 3 into 2 doesn't go. 2 left over. 3 into 21, that goes 7 times with no remainder. Then 3 into nothing goes no times. So there we are. So that gives us then 70. And that is the final answer. Very similar then, work out 3/4 of 180. So same thing as what we did last time. I'm going to do 3/4 Then of, remember, means times, so times, then 180. Then again, trying to do a fraction times by a non-fraction, it's not going to work. So what we do there is just divide it by 1, make it a fraction, and then times it together. 3 times 180 is 540, there we are. And then divided by 4 times 1, 4. Okie dokie. And then from there, let's see what else we can do. Can we simplify that? Yes, we can. Divide them both by 2. 545 by 2. Let's have a think then. So that's 500. That's 250 plus 20. That's 270 over 2. Divided by 4 as well. And then, by 4 by 2 as well. And then divide that by 2 again. That's 135 over 1, which is just 135. And there we are. Next up then, let's put in a bit of context. So, the normal price of a computer game is £40. The price is reduced by 1/5 in a sale. Work out the price of the computer game in the sale. Okie dokie then. So, first thing we need to do is find the fifth of this 40, right? Because it's been reduced by that amount. We need to figure out what that amount is, okay? Then we're going to do 1/5 of 40, which is, as we know, 1/5, and then times 40 over 1, which is then 40 divided by 5, 40 over 5, which is then 8. There we are. So then we know that 1/5 of 40, that's £8. So it's been reduced by a fifth, it's been reduced by £8. So we're going to do £40, take away £8, which is then £32. And there we are, that is that. Okay, next up then we've got the Edexcel June 2019 paper 1. So again, paper 1, which is non-calculator. So pause it, have a go, see how you get on. Question 9, work out 3.5 times 1 3/5. Give your answer as a mixed number in its simplest form. Okay then, so remember these are mixed fractions or mixed numbers. Don't want to deal with them, let's make them improper. So we've got 3.5, and that becomes 3 times 2, 6 plus 1, 7 over 2. And that's times by 1 3/5, which is going to become 1 times 5, 5 plus 3, 8/5. And then 7 over 2 times 8/5. 7 times 8, that's 56. And 2 times 5, that's 10. Then can we simplify this? Yes, we can. These are both even, so divide them by 2. That's going to then get us, 25, 6, 7, 28 over 5. Then can we divide that by anything else? No, we can't, because 5 is prime. So if 5 is over 28, nothing's going to go in, right? So let's move on then. So can we then make this into a mixed number? Yes, we can. So how do we do that? We figure out how many 5s there are in 28. That's going to be 5. It's because 5 to 25. That's going to be the next one. So then we've got 5 out of 25, 26, 27, 28. We've got 3 left over out, and then out of 5 from that one there. So 5 3/5. And there we have it. And that is that. Okay, next question then. It's an AQA question from June 2017. Again, paper 1, so non-calculator. A little bit of a tricky one, this one, so try your best. Pause it, have a go, see how you get on. Okay, so question 7. 3/5 of a number is 162. Work out the number. Okay, so 3/5 of some number. Let's call that n. We don't know what that is, but 3/5 of n, that's going to be 162. Okie dokie then. So let's then kind of change this to something a bit nicer. So 3/5 of, I know means times. So let's put a time sign in there, make it a bit of an equation, right? So 3/5 and times n is 162. Then we want to figure out what n is. We try and get n on its own. So a bit of kind of like algebra going on here. So we need to then divide this down there, and we get 162 divided by 3/5. There's a couple of different ways to do this. Is the way that I like though. So 162 divided by 3/5. So if you've got a different method, don't worry, as long as it gets to the right answer at the end. And then what I would do from there is we've got a number with a fraction. So let's make this into a number as well, as we did earlier, by putting a 1 under it. So we've got 162 divided over 1, divided by 3/5. So then keep, flip, change, KFC. So we're going to keep the first one, so 162 over 1, flip the second, 5 over 3 and then times. We're in our space here. There's some rather awkward spacing, haven't I? So let's then continue. So 102 times 5, whatever that may be. Let's put that up here. 162 and 5, 810. Okay, so that's 810 over 3. And then will that divide by 3? Let's check. So 8 plus 1 is 9. So that's a multiple of 3. So it will divide by 3. So let's do that. I'm going to put that down there. So then we're left with 270. And there we are. And that was the 2 marks. Okay, the next question. So then we're going AQA November 2017 paper 2 question. Paper 2 calculator. Hooray. And we need a calculator for this one. Question 14 now, so now we're moving further along through the higher papers. Everything else was on the higher paper, just like question 1, 2, 3 and the like, right? But question 14, we're really getting on a bit now, so it's going to be a little bit harder. And as you can see from this being a bit of a context question, right? So it's still fractions, just in a context this time. So pause it, have a go, try your best to see how you get on. Okay, then question 14. A ball is thrown from a height of 15 meters. It bounces to a height h1, okay, and then to a height h2. Right. h1 is 3/4 of the original height. 14a. Jack expects h2 to be 3/4 of h1. Work out the value of h2 that he expects. Okay, then so first thing I'm going to do is kind of hone in on this sentence here. So they've said that h1 is going to be equal to, because is 3/4, which is this fraction here, 3/4 of the original height, which is this 15 here, the height it was originally thrown at, which is 15. Okay, and then we know how to deal with this, don't we? We know what of means. So h1 is then going to be 3/4 times 15. Then we've got a fraction times by numbers. Let's make that into a fraction too. So then we've got 3/4 times by 15 over 1, which is then 15, 30, 45 over 4. Okay, and then that is that. That is then h1, 45 over 4. Which you could make into a decimal if you wanted to, but doesn't matter, we're going to leave it as is for now. And then, what does he want us to do? Work out the value of h2. So Jack expects h2 to also be 3/4 of h1. Okay, so then h2 is then going to be another 3/4 of, so times h1, which is this one here. Okay, over 4, and then I need to calculate for that, because 45 times 3, what is that? I don't know. 45 over 4 times 3/4. In mental maths, never been my strong suit. It's written maths, I'm pretty good, but mental maths, I am rubbish. 135 over 6. And then as a decimal, see if it's any good. No, it's not. But we'll write it anyway, just for good measure. Why not? 8.437. But if you put this on there, that would also be absolutely fine, this fraction here. And there we are. That will be 2 marks. Okay, next up then, we've got an AQA paper from June 2018. It's the paper 1, which is the non-calculator paper. Question 23 now, so we're really getting near the end of the higher paper at this point. So if you're finding it tricky, don't worry. It's meant to be tricky, right? It's end of the high paper. It's not meant to be a walk in the park. It's meant to be quite tough. Pause it, have a go, see how you get on. But yeah, we'll go through in a second. Okay, then question 23. A shopkeeper compares the income from sales of a laptop in March and April. So in April, the price was a fifth more than March, and then in April, the number sold was a quarter less than March. Okay, by what fraction does the income from the sales decrease in April? Okay then, sir, what a painful question. So let's have a look then, sir. I'm going to make some algebra out of this, I think. The price in April is going to be a fifth more than March. It's going to be what it was in March plus an extra fifth of what it was in March. Does that make sense? So a fifth more than March, so whatever it was in March plus a fifth more of that value, right? And then the number sold, so the number sold in April is then going to be the number sold in March take away a quarter of what they sold in March. Right, okie dokie then. So, and then want to bring these guys together, so remember, whenever we're adding or subtracting a number from, a fraction from a number, they need to make the number into a fraction of its own. So 1 over 1 plus 1 over 5 is going to become 5 over 5 plus 1 over 5, which is 6 over 5. So that one then gives us 6/5 m. And then same thing here, 1 take away a quarter, so then we've got 4 over 4, 1 over 1 times 4, take away 1 over 4, which is 3 over 4. So that is then 3 over 4m. Okay, then the income is going to be from the number of computers they sold, and then in April, multiply by the profit for each computer. Does that make sense? Because if they earn £2 a computer and sell 10 computers, then they're going to get 20 quid, right? £2 per computer. So that's a times that you're doing there. So income, then you're going to get NA, which is then this 6/5 m. So it's going to be 6. Oh no, it's not. It's going to be the 3/4. My apologies. 3/4 m. Switch them around, haven't I? 3/4 of m, but m is going to be the same. It's just of m essentially, multiplied by this 6/5, which is then going to be 3 times 6, which is 18 over 20. Simplify that, divide it by 2, 9 over 10. So then we have got 9/10 essentially of what it was. Does that make sense? Stopped writing it. But 9/10 m. Essentially, if we put this m back. So April is then 9/10 of m, which is what we've worked out here. So then it must have decreased by 1/10, because it's 9/10 of what it was. So the actual decrease is that one more to make it 10 out of 10, to make it the same as it was before, right? Because if it was 10/10 m, then it'd just be 1 to 1 with m, then it'd just be the same thing as what it was before. But it is not. It's been times by 9/10, which essentially made it like 90% of what it was. So it's like gone down by 10% essentially, or the fraction, that's 1/10. So really tricky question. It was really, really tough. And well done if you managed to get far with that. It was really, really, really tricky. But yeah, that one was 3 marks. Okay, then the next tricky question then. So AQA, June 2017, paper 1. Again, paper 1, non-calculator. And again, AQA. Maybe it's one a pattern here. AQA like to ask really finicky questions, to be honest. So, pause it, have a go, see how you get on. Again, remember, it's meant to be tricky. This is like right near the end of the paper. Like we're really, really, really close to the end now. So it's meant to be really challenging. So just see how far you can get. 4 marks, let's pick up some method marks, right? So pause it, have a go, see how you get on, try your best. Okay, last question then, question 25. In an office, there are twice as many females as males. A quarter of the females wear glasses, 3/8 of the males wear glasses. 84 people in the office wear glasses. Work out the number of people in the office. Okie dokie then. So, quite a poorly worded question, I think. Choice of the word females aside, but what I would do here is convert this from words into algebra, because I don't like words in my maths, right? Wordy math questions are the bane of everyone's existence. So what I would do is convert it all into algebra. So in an office there are twice as many women as men, so there are going to be twice, so for the females there's going to be twice as many men, so F is going to be 2 times the number of men, because it's going to be double as many essentially. So then next up, the quarter of all the females wear glasses. So the females who wear glasses, is going to be a quarter of the total number of females. Okay, and then 3/8 of the males wear glasses. So then the males who wear glasses is going to be 3/8 of the total number of males. Right. And then 84 people in the office wear glasses. So the females who wear glasses plus the males who wear glasses is going to be 84. Okie dokie then. And then we can start kind of just putting all these equations together, just combining them all into kind of one equation. So let's put these two into there. So females who wear glasses, that's a quarter of all the females. That's a quarter of all the females. And the males who wear glasses, that's then 3/8 of all the males. And that is 84. Okay, and then that's those two put in. And then into that one. And then this one here. So the number of females is twice the number of males. So we could replace this F here with this 2m. So a quarter times 2m, but a substitution. Substitute this one into this one. is then plus 3/8 equals 84. So then 1/4 times 2, that's going to be 1/4 times 2/1, which is 2/4, which is a half. So then we've got, this up here, so we've got a bit more space, a half m plus 3/8 equals 84. So we've got a half plus 3/8, that's the next sum. Add these together. So then times this one by 4, and you get, what is that, 4 out of 8 plus 3 out of 8. Oops, you can't see it anymore, can you? Shuffle that down a little bit. And then that's going to then be 7 out of 8. Okie dokie then. So then, let's have a look. So we've got 7/8. I've run out of space, haven't I? 7/8 because I added them together, that is then 84. So that's where we are now. 7/8 equals 84. So to summarise, we went through, we changed all this into algebra, we then put all the equations together, we then simplified the equation by adding these together to make it 7/8 equals 84. Then I'm going to bring this down here a little bit, so I've got a bit more space. And then because I get m on its own, number of males, I'm going to divide by this. So I'm going to do 84 divided by 7/8, which is then keep flip change, 84/1 times by 8/7, which is then going to be 84 times 8, which is 32. 8 times 8 is 64. 64, 65, 667. Oopsie, 672. Yep. 672. And then over 7. And then let's divide those. So it's going to be 96 men or males. And then, golly gosh, never ends, does it? Going back to the top, number of females is twice the number of males. We've got the number of males is 96. The number of females is then going to be 96 times 2, which is then 192. There we are. And then add them together. 192 plus 96, 288. Oh, that was that. That's all of it. What a funny question. So that is it. So that was day 4 of my 25 days for Best Masquerade series. I hope you've enjoyed. If you did, remember to leave a like, subscribe, all that YouTube stuff. Be back again same time tomorrow, 6 o'clock, with my next video on compound interest. So be there, or be square, as the maths people put it. But there we are. So yeah, have the rest of your night. I'll see you tomorrow. Bye.